All right, today's lecture. Welcome back, you guys. To your favorite trig course. We're gonna talk about the law of sines. So here's put this over here. Here's our law of sines, right? And this is for oblique, excuse me, triangles. And I do think it's important just to kind of note where this comes from. Let me. So here's your proof of the law of sines. If you take oblique or non-right triangle, let's go ahead and label all our angles, capital A, capital B, capital C. I'm going to go ahead and label the opposite side lengths A. So see how that's opposite angle A. And then I'm going to label opposite B, side length B. I'm going to label opposite C, side length C. And what I'm going to do here, number one, is I'm going to go ahead and draw, let me draw my altitude. So the straight down, H, the height of that triangle, from angle B down to the opposite side, is H. And so if I take the sine of C, so the sine of angle C right there would be opposite over its hypotenuse, right? You see that right triangle there? So notice that the sine of C is opposite over hypotenuse. And if I go over to angle A here, and I look at, and so I'm looking at this triangle now, this right triangle right there, then I know the sine of A is opposite over hypotenuse as well, right? So I know the sine of angle A is opposite over hypotenuse. Well, if you notice both of these, I can solve for H. So let me multiply by A. So I have H equals A sine of angle C. Over here, I'm going to solve for H as well. H equals C sine of A. So I know H equals H, right? And so A sine of C, which is equal to H here, must equal C sine of A over there. And now let me put it in the law of sines form. So let me divide both sides by C here. And let me divide both sides by A over here. And so I have the sine of C over lowercase c equals the sine of A over lowercase a. There's my law of sines. Let's go back to the law of sines, right? So sine of A over A equals sine of C over C. Similarly, you could do that for B over B, but that's where it comes from. Let me erase this a little bit here. So the law of sines is useful for solving oblique or non-right triangles of these three forms, where I'm given an angle, a side length, and an angle. So that's referred to as angle side angle. Or second scenario, if you're given an angle, and a side, right? Angle, side, or side, angle. And the third scenario, let me put a squiggly here, is where you have a side length, given, and an angle. So angle side or side angle. And this one is what's referred to as the ambiguous case in many textbooks. And that's because it's a pain in this is how I remember it, ASS, right? It's kind of a pain in the butt, and it's a pain in the butt because you could have no solution. Well, first of all, you could have one solution, you could have no solution, or you could have two solutions. So there's different cases, there's different options. Whereas with these two, it's just straightforward. You just got one solution, you just plug and chug and go at it. So let's look at the first example here. And let's see what we're given. Can you see how you have an angle and then the side length, right? So we have angle, angle, side, right? Or if you want to say it, side, angle, angle, right? And so that's this one right here, right? Side, angle, 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 side. So law sines is what applies for us. And what we're going to do is we're going to start out and say, well, number one, since I have two of the three sides, let's go ahead and solve for angle C. And I should say, before I do that, let's label all the sides. So opposite angle B is just a lowercase b. Opposite angle C is lowercase c. That's that side length over there, lowercase c. Okay. Now let's go ahead and say, well, 40 degrees, angle A plus angle B plus angle C. We know all the interior angles of a triangle add up to 180 degrees, right? So we got 100 degrees plus angle C is 180. Let's solve for angle C. 180 minus 100, we got 80 degrees, right? So angle C, now let's go ahead and fill that in. That's 80 degrees, right? We're supposed to solve the triangle. When they say solve the triangle, that means find all the remaining angles, the missing angles and missing side lengths, right? Now, number two, now we're going to use the law of sines, right? The law of sines says sine of A over A equals the sine of angle B over side length B equals the sine of C over side length C. Now, notice we have given angle A, we know that's 40 degrees. Side length A, that's a 4. And we have angle B, right? And so which ones am I going to pick? I'm going to pick those two because now I can solve for side length B right there. Now, I know I have angle C too because I solved for that in step number 1, but I'm going to ignore that for just a second. Let's just go through and solve sine of 40 degrees over lowercase a, which is 4, right? This is lowercase a right there. Equals the sine of 60 degrees over b. And now let's cross multiply. So we got 4 times the sine of 60 degrees equals b times the sine of 40 degrees. And so let's solve for b. Remember, sine of 40 degrees is just a number. And so we've got b equals 4 times the sine of 60 degrees all over the sine of 40 degrees. And so let's punch that in. Here we're going to pull up Desmos. Well done, scientific calculator. First thing I'm going to check, make sure you're in degrees. Notice I have degrees. And right here I'm in degrees, right? If I want to switch that, of course you can switch in radians. Make sure you're in degrees. I have 4 times the sine of, it was 60 degrees divided by sine of 40 degrees. So 5.389. I'm going to go ahead and write that in. Right here, let me flip this back over. So B, let me just round that to 5.39. Okay, so now we have side length B. So this is 5.39 side length. All right. We just have one more step here. We have our angle C was 80 degrees. We have lowercase b, side length B, 5.39. Now we need to find side length C. So we have sine of A over, sine of angle A over side length A equals, now we need to do sine of C. We know angle C is 80 degrees over lowercase c. And let's go through that same process. C times the sine of 40 degrees equals 4. Sine of 80 degrees, divide both sides by sine of 40 degrees. And we got C equals, and then I punch this in. Let's see, 4 sine 80. Let's see, we got right here 6.1283554545. So about 6.13. Here, notice we have an angle, a side, and an angle, right? Angle, side, angle. So this is the first scenario again. These two have no issues, right? This one's an angle, side, angle. It's that one right there. And so it's straightforward as well. We just go ahead and start solving. It's not the ambiguous case. So since we have two of the three angles given, I'm going to start out doing that. So number one, well, and let me label my side lengths. This would be side length A, this would be side length B. It looks like I'm given side length C right there. So angle A is 35 degrees, angle B is 15 degrees. Angle C, I don't know. Looks like it's an obtuse angle if this is drawn to scale. 35 plus 15, got 50 degrees. Subtract 50 from both sides, so it looks like I got 130 degrees is my angle C. Alright, so angle C, 130 degrees. Number two. Notice we're given we were given initially side length C, we were given angle A, and we were given angle B, right? But we did solve for angle C, right? And so let's go ahead and we can do any two of those, but we're going to have to use angle C and C, right? So we have to have 3 of the 4 there to solve for the remaining variable. So sine of 15 degrees over B would equal to the sine of 130 degrees over side length C, which is 5. Go ahead, cross multiply, so I got 5 times the sine of 15 degrees equals B, sine of 130, divide both sides by sine of 130. And so B equals, let me punch that in, 5 times sine of 15, sine of 130. 1.6893234, so about, I'll round this, 1.69. Alright, so now we just need side length A. So step 3, I got sine of 130, sine of C over C equals sine of A, which is 35 degrees, over lowercase a. I don't know lowercase a side length. And we're going to go ahead and cross multiply again. Divide by sine 130. And so about 3.74. Again, make sure your calculator's in degrees when you punch that in. Alright, let's get into our last scenario with lost signs, and then we'll do a bunch of these types of examples. Notice I'm given an angle, a side, and a side. this is the pane in the ASS, right, or side angle. This is the pane in the ASS. This is the ambiguous case, okay? And so with the ambiguous case, you just got to be careful with it. You should be able to kind of walk yourself through it. But just know that there are three options with the ambiguous case. You'll either have one solution, two solutions, two possible triangles, or no solution. And we'll do examples of each of those scenarios, okay? And all right, let's go through. Let's start filling in angle C. And notice I have, with the lost signs here, I have sine of A over A, and I have lowercase b as well. So I'm going to use sine of B over B. So I have sine of 48 degrees over the 3. Right, this is my A right there. Sine of B, I don't know B, but it's over 2. Right? And so here, if I go ahead cross multiply, I got 2 sine 40 degrees equals 3 sine of B. So if I divide both sides by 3, I get the sine of B equals 2 sine of 40 degrees over 3, right? So if you punch in 2 sine of 40 degrees over 3, let's see what that is here. Desmos. .428, right? 4285. Push that in. So sine of B equals 0.4285, right? And now, if you think about that for a minute, on your unit circle, you have a sine value is 0.4285. That could happen at 2 spots, right? It could happen at that angle, whatever that is, or it could happen at that angle. I'll call that beta, okay? But when I'm taking the arcsine here, it's only giving me that first one. So I run the arcsine, so angle B is the arcsine of 0.4285. Make sure you're in degrees when you do that. Let me go back to decimals and let's punch that in. Sine of 0.4285. So where's my decimals here? So I'm going to go into the functions, FUNC right there, arcsine, that answer right there. So I could just use ANS. That'll bring that whole thing down for me. And then this is exact. So 25.3799394. Right, so I don't have any rounding error. Let me go back to this. Let's see. So 25.37 degrees if I round that. So that's my alpha, right? Is 25.37. Now the reason I bring up is there's a possible, could it also be beta, right? What would beta be? Well, if it's 25.37 degrees up, that reference angle, then the second option would be 180 minus 25.37 degrees, So if I were drawing, which would be, what's that? 154.63 degrees. So the question is, could I have an angle B that instead of being an acute angle is an obtuse angle? Let's see if I could draw that. Could I have an angle B right there like that instead, right? Well, this is not possible because angle A is 40. We're claiming angle B is 154.63. But if I add those two up, and then angle C, remember this has got to be 180. This is too much, 194.63. So there's no way, I don't have a second option for angle B. Okay. So let me erase that. So I only have one solution to this one is what I'm saying. I only have one solution. I've ruled out two solutions. Okay. And I know I don't have no solutions because when I take the arc sine, it gives me a value 25.37. Okay. Now, I did attach a handout, and so let me talk about that. This is an appropriate time to talk about this picture here. Okay, if you want to use this, you can. You don't necessarily have to walk through with it. But our given angle was acute. Here, let me split this a little bit. The given angle is angle A here. Okay, angle A. Well, in the diagram that we just had, oops, we had it was like this: A, B, C, and we had the 40 degrees right there. Okay, so our angle was acute. Okay, not obtuse. So this does not apply right there. And then its opposite side was the A, and so if you're looking at this, if the angle A is acute, and if A, oops, the B was 2. If the A is greater than or equal to the B, so we're right here, then I know I only have one possible solution. In other words, only one triangle will work. Okay. Whereas if it would have been less than B but greater than the altitude, I'd have two solutions. And then finally, we'll do these other solutions. We'll get to those, but I'm just trying to kind of explain. If you want to use this to walk you through it, you can. You may not have to. If you work the math right, you should be fine. But I think it's kind of valuable just to see it laid out. All right, so we've solved for angle B. Now that we know angle B is 25.37 degrees, step 2 is we say, well, 40 degrees plus the 25.37 degrees plus the angle C, all of them add up to 180, right? All three angles. And so angle C ends up being 114.63 degrees. All right, 114.63 degrees. And now we can just use law sines to find side length C. So sine of capital C over side length C equals, and I could use, maybe we'll use the A, sine of 40 degrees. We were given that initially over lowercase a right there. Go ahead, cross multiply. Remember, sine of 40 is just a number, so I got to divide both sides by sine of 40 here. And so C ends up being 3 times the sine of 114.63 divided by sine of 40, or 4.24, rounded, right, approximately. And we solved that. So that was a one solution scenario. All right, this next one. So let's look at it. Again, we have an angle, side, side. So another pane in the ASS. So we have, it could be one solution, it could be two solutions, or it could be no solution. Okay. So let's walk through possibilities. This would be lowercase b, this would be lowercase c, this would be lowercase a. And let's start looking at this. We got sine of 50 degrees, so sine of c. We have capital C and lowercase c. And let's do it with sine of a because we have lowercase a. Right, we have those. Right? Oh, I'm sorry. We have those. That's a lowercase a. So we have sine of 50 degrees over lowercase c is 1 equals the sine of a, we don't know capital A yet, over lowercase a is 2. Let's cross multiply. 2 times the sine of 50 equals the sine of a, 1 times the sine of a. So we have sine of a. I'm going to go ahead and punch in 2 times the sine of 50 degrees in decimals. Again, make sure you're in degrees. And so the sine of a is 1.5320888886. Okay, that's what the sine of a is. Well, we know that's not possible. Like the sine of a will never be more than 1, right? We never have a sine value that's more than 1. So even if you run the arc sine right here, if I run the arc sine on both sides to solve for a, so a, angle A is the arc sine 1.53, right? And I punch that in, and you'll see that it's undefined or no solution if you punch that in. No solution. It's not possible, right? If you also want to think about it in terms of the arc sine, remember the domain of the arc sine is between -1 and 1. I can't take an arc sine of something more than 1, right? So this has no solution. And so let's talk about this as far as the handout is concerned. Our given angle was 50 degrees. I know I labeled it was angle C in the original problem, but our given angle is angle A. And so it's a Q, right? So we're looking at one of these 4 scenarios, and its side length was 1, and notice that that is less than the 2 given. 1 is less than 2, okay? But the problem is, if you compare it to H, like this doesn't, there's no way for it to attach. It's too short. If you draw the height in here and you solve for that, the sine of 50 degrees is H over 2. So H is 2 sine of 50. So the H here is 1.53. Can you see how the A, which is 1, is less than the height, 1.53, this height right there? So it cannot attach. It's too short to attach. Okay, so it cannot make a triangle. That's why it doesn't work. That's why you get that no solution situation, right? All right, next one we've got an angle, a side, and a side again. Angle, side, side. Another pane in the SS, right? So we got the ambiguous case. So we got to decide, is it one solution? Is it two solutions? Or is it no solutions as we work through this, right? So let's start working through this. I got number one, the sine of 25 degrees over lowercase c. So it's lowercase c right there. Equals the sine of a over lowercase a, which is 2. Let's cross multiply. So 1 times the sine of a is just the sine of a. 2 times the sine of 25 degrees is 2 times the sine of 25 degrees. We punch in 2 times the sine of 25 degrees in my decimals. I get 0.845. This keeps going. And so again, think to yourself, I have two spots where the sine could be 0.845, right? I'm going to unit circle here. Unit circle. Two spots where it could be the sine of a is 0.845. Could be that alpha, or it could be the beta. Okay. When I run the arc sine, it's only going to give me the alpha. So angle A is, and I'm going to punch in arc sine 0.845, blah, 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 0.845, 236. And I get 57.697, 28627. So we're about 57.7 degrees, okay? So that's like my alpha. So that would be for the first option. Now note, if this is 57.7, this over here would have to go up 57.7. So the second option for triangle 2 second option, I'm going to call it angle A2, which is the beta angle, would be 180 minus the 57.7. So angle A2 could be 122.3 degrees. Let's see. Let me erase this for a second. And could that work? So let's think about this for a minute. Could I have a different angle A that's not the 57.7? That's the acute angle. In other words, could I take this arm and swing it over so that this still stays a length of 1? Yes, I could. And so that's my angle A2, 122.3 degrees. How do I know that? Well, 25 plus 122.3 plus whatever angle B is, I can still get, that's still less than 180. So that the missing angle would be like 32.7, right? So it'll work, right? Again, what you're looking at is you're taking this arm and swinging it over right there. And so that becomes your angle A now. So angle A becomes an obtuse. So you have two options. You have triangle 1, which is how it's drawn, and then the triangle 2 with the obtuse angle that I just erased. Okay? So we'll keep these totally separate. Let's continue on with triangle 1. which has an angle of 57.7 degrees. And let's solve for the rest of it. So number 2, 25 degrees angle C plus 57.7 degrees plus angle B all add up to 180. So angle B would be, let's see, that'd be 97.3 degrees would be angle B. And then we'll just use our law of sines. So we'll say the sine of 25 degrees over lowercase c equals the sine of 97.3 degrees over the missing lowercase b. Cross multiply. B times the sine of 25 equals 1 times the sine of 97.3. Divide both sides by the sine of 25. And so B ends up being about 2.35. Okay, so that's for that triangle 1, right? Remember, we have a 2-solution scenario, right? We have a 2-solution scenario. And back to the handout, that's because the given angle was acute. A was less than B, so this angle was 25 degrees, and 1 is less than 2, but it's also greater than, 1 is less than 2, but it's greater than the h. I didn't solve for the h, but the h would have been sine of 25 equals h over 2, and so the h was 0.845. 0.845. Right? So that's why I know I have 2 solutions here. Okay, if you're using the handout, again, you don't have to, want to, but you should be able to figure it out for the math. Regardless, let's keep going with this, and let's go ahead and draw what this thing is looking like. Anyways, so we've swung that arm around. Let's see if I can draw that down here. Swung that around right there. So 1, 2, 25 degrees. This was C, B, A, lowercase a. And then we found angle 2 is 180 minus the original angle A from the first triangle, right? We know it's got to be 180 minus that, 122.3. That was step 1. Step 2 then is to say, well, if I know that's 122.3, then 25 degrees plus 122.3 degrees plus angle B all add up to 180 degrees. And angle B would then end up being 32.7 degrees. And the last thing we got to solve for is sine of 25 degrees over lowercase c equals sine 32.7 degrees over lowercase b, cross multiply. Oops, my c here was 1, sorry about that. Divide by sine 25. So we got sine of 32.7 divided by sine 25 degrees, and get 1.28. And there's my triangle 2. So 2 solutions again on this one, right? All right, let's keep going. Some more of these. All right, we've got another angle side. And so we got another pain in the ASS, right? So it could be one solution, could be two solutions, could be no solutions, right, on this. And so we'll start out and start working this problem, and we'll see how we do here. Number one, we know that the sine of b here, given angle, over lowercase b, this is lowercase b, equals sine of c over lowercase c. Divide both sides by 4. So we get the sine of c equals 3 times sine of 40 degrees over 4. So I get 0.482 blah, 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 right? I'm going to go ahead and run the arc sine on both sides. And so it spits out, the arc sine gives me 28.82, right? And remember, if the sine of c equals 0.482, there's two spots where that could happen, right? Alpha or beta, right? And so here's the alpha option, 28.82. The arc sine is only going to spit that one out. So possible triangle 2 would be, I'm going to call it angle C2, which would be the beta, would be the 180 minus 28.82. So that would give me a possible 151.18. But the problem with that is, so let me draw that triangle. Have 40 degrees. I won't even draw this stupid thing. 40 degrees, 151 degrees, plus angle A cannot be 180 degrees, right? This is too much. I got 191.18 already. So there is no possible triangle 2. So this is only one solution on this, right? One solution on this. So if you're looking at your handout, your given angle is acute, and you have that scenario right there. Right? All right, let's keep going with this. Let me get this out of the way now. And we've got on to step 2. Now we know sine, or we know angle C, so we can find, so we got 40 degrees. That's our angle B. Angle C is 28.82 degrees. That's 28.82 degrees in there. Plus angle A all adds up to 180. So angle A has got to be 111.18 degrees. And finally, sine of 40 degrees over sine of B over B equals sine of A all over lowercase a. Divide by sine of 40. Both sides. And we get about 5.8 on that. All right, let's look at this last example where we've got an angle, a side, and a side. Lost signs, pain in the butt again, ASS again. So we got to determine if it's one solution, two solutions, or no solution again, right? And let's go ahead and put in our letters here. And let's start out solving this thing. So we have, let's see, so number one, we got the sine of 40 degrees over, so sine of B over the B equals, we don't know capital C, but we do know lowercase c. So 4 sine of C equals 5 sine of 40 divided by 4. So sine of C equals 0.8035, it looks like, 0.8035. So, there's two spots where you have a sine that's 0.8035. Two angles, I should say. Alpha or beta, right? So when I run this arc sine, it's only going to pop out the alpha because we had to restrict sine in order to find an arc sine. So let's punch in arc sine 0.8035. I get 53.46 degrees. Okay. So what would the other angle be, right? So this is 53.46 degrees. So that's saying this angle C, of course, 53.46 degrees. So the other option, triangle 2, if I was to consider triangle 2, I'm going to call that angle C2, would be 180 minus 53.46 degrees. That's the beta right here, right? And so that would be 126.54. And let's see if we can draw that. Get you a feel for this. And is that even possible? Well, if we take this arm right here and we rotate it over to there, same length, right? Then that changes angle C to being obtuse. And so could this work? Well, if this angle is 126.54 degrees, then step 1, step 2, then 40 plus 126.54 degrees plus angle A, I'll call it angle A2. Call that angle A2 because it's on the second triangle. Then angle A2, yeah, that'll work. That'd be 13.46 degrees, right? Because I'd have 40 plus 126.54, 66.54, which is less than 180, right? And then I can finish out this triangle. So sine of 40 degrees over 4 equals the sine of 13.46 over A. And so your A, or I could call it A2 if you want, little A2, side length A2, that ends up being 1.45. Okay, so we solve for triangle 2. Let's go back up, let's finish the original. With 53.46, that angle being acute. So we got 40 degrees for angle B, 53.46 degrees for angle C. What's angle A? They all add up to 180. So angle A would have to be 86.54 degrees. And now I can set up my loss sign. So I have sine of 40 degrees over 4 equals a sine of 86.54 over A, and then A ends up being 6.21. And that should be good. That's quite a few scenarios. Hopefully that helps you guys get started on this assignment, Lost Science. Thanks for watching. See you next time.